So the plan today is test outline, and then I'll work some of the odds from the review that I pick, and then I'll work any of the odds that you like, and then I'll let you have the rest of the time to work on it, study, review, whatever you need to do for the test. Okay, so test outline 19 multiple choice. Times 2 each adds up to 38 total points. By the way, of those multiple choice, 6 are just like the first 6 on the review, like parent function matching, like just match the basic function to get you started. So that should be a free 12 points right there, hopefully. There are 5 graphs, 4 with the grid, 1 no grid. So with the grid are a little bit easier. Without the grid, you've got to be the one that is careful about where you put the spacing on things. Those will be worth 6 points each because there's lots of pieces to those. Most of those have the questions that go with them. Like, what's the amplitude? Is there a flip? What's the period? So lots of partial credit on those. And then lastly, there are 12 unit circle questions. Times 2 each makes 24. And if you add all that up, it only comes to 92. So free 8 points for putting your name on the test, showing up, and just being great people all around.
The unit circle, we're really just going to be like sin 7 pi over 6.
Yep, the unit circle ones will be very straightforward. Like sine of 7 pi over 6. So, Noah, what is the sine of 7 pi over 6? You give the question, let somebody else give the answer. JD's writing it in the air, and I think he wrote it correctly. What did you write? JD, tell me what you wrote. Negative 1/2. But yes, they're all straightforward like that. Nothing crazy. Any questions on test outline, what it looks like? Again, very much like the review, not as long. I think you'll be fine, but find out tomorrow. Okay, so let's look at worksheet 5, the review worksheet. Again, I've picked some out that I want to work, and then I'll take your questions on if you've still got things you want to see. Again, the first 6 on the review are exactly like the first 6 on the test. I mean, like, don't memorize the letters because I think that they've been scrambled, but it's the same 6 questions, like just matching the parent function with the equation. It's a good way to start. That way your brain kind of gets set into what's what, and then you can start making all the adjustments after that. But let's go to number 9. We talked a little bit about these yesterday, where that one graph could have an infinite number of equations, so it's a little bit tricky. Which is an equation of the given graph? Let's see. Let's remind ourselves. That's what sine looks like. That's what cosine looks like. So, I don't know. I guess we should start with the answer choices because we could write literally a million different equations for this graph. So, I would not start with the graph and write an equation because you might hit one of those, but you might not. So, negative 3 sine x. Let's see. So that would be sine but flipped. So that would look like that. So that's out. Negative 3 sine x minus pi over 2. So that would mean right pi over 2 and then a negative sine wave. There's right pi over 2, but that's a positive sine wave, so B's out. Part C, left pi over 2, but also flipped. Left pi over 2 would put us there, and that's a flip sine wave, so I'm pretty sure it's C. 3 cosine, well, that would look like a regular cosine but stretched. That's not right because it's flipped. So that's to illustrate. You got to be able to quickly recognize what the transformations are and did they happen for this particular graph. Any questions on that one? I feel like I went through that pretty quick. I hope you can get through them almost that quick anyway. Let's look at number 13. I think this is an easy one, but we hadn't done one in a little bit. So write an equation of a sine function. An equation, that means y equals. Sine function means use sine, not cosine or tangent. With an amplitude of 5. It's my favorite part because now I get to use all the colors. Amplitude of 5. A phase shift of left pi over 3. So that would be x plus pi over 3. A vertical shift of down 7. Minus 7. And a period of 4. Okay, period is 2 pi over b. So that means 4 equals 2 pi over b. Then you got to put your algebra hat on and rearrange some things. And b equals 2 pi over 4 or pi over 2. That one would be a terrible one to graph, but we're not asking you to graph it, just write the equation. So I feel like those are straightforward, but I also don't think we did one of those yesterday. So
when it says a period of 4 units, that's what you're putting the equation equal to? I guess that makes sense when you're asking.
yeah, that's a good way to say it, because the equation is period equals 2 pi over b. Sometimes we give you the period and you solve for b. Other times we give you the equation, which means you get b and you solve for the period. So if it tells you the period, you put 4 in for period.
What would it say if it was for b?
So it probably would never say b is equal to 2.
Yeah.
It would probably give you an equation, looking for one that has an obvious b in it, and I don't see one. So if there was an equation that said y equals 3 cosine 2 x minus pi plus 1. Separate equation altogether. And we ask what's the period of that? Well, what's the b for that equation? So b is 2. Period equals 2 pi over b. So that period would be pi. So yes, that's the kind of the opposite of what we did in number 13. So the equation is the same, period equals 2 pi over b, but be careful about what we give you versus what we're asking. Let's turn to 17. Negative cosine. I'm going to start by graphing a little picture of cosine there. Negative, so it's flipped. Minus pi over 2, so right pi over 2, and up 1. And we like it when the grid is given, it makes things a little easier. Right pi over 2, up 1. Will be right there. So there's our new origin. Again, if you really like, you can put the whole new midline on there if you want to make sure you're oscillating around that axis. Again, I think I've showed you this before. When people do that, it's one of the most frustrating mistakes. When I see this, and then their graph is, you're like, come on, like you graph the midline, like make it the midline. So the midline is helpful as long as you understand that I would call it the midline. Don't do that. Back to 17. So there's my starting point. There's the period's 2 pi, so I don't have to worry about that. Be careful though, that doesn't mean you go to 2 pi, that means you go 2 pi away. And let's see, cosine starts at a max, although this one's flipped, so it starts at a min, which means it ends at a min. In the middle is usually a minimum, but this one's flipped, so it's maximum. And in between the maximums and the minimums are the midline points. And again, don't make a mountain, make a cosine wave. And it does say graph it from negative 2 pi to 2 pi, so I need to extend this graph back. Remember, there's a couple ways to do that. If it's nice and gridded out like this, you might just follow the pattern, up, down, so on, which is fine. Or you could go 2 pi away and sort of copy paste that picture back one spot. But that follows the pattern. So either way, whether you're a pattern follower or a copy paster, there's our cosine graph, excuse me. And I think you'll have time. Take the extra 5 seconds to make sure that what you said would happen is in fact on the graph, because very rarely does anybody miss explaining what's going to happen, but sometimes they forget to do one of those things. So when you finish, make sure flipped, yes, it's flipped, right pi over 2 and up 1, yeah, we did those things.
Why don't you start on the thing that you marked in the origin? Like, why doesn't the line start there?
Okay, good question. Why don't we start at the origin? Like, we mark that as our new origin. Why don't we start there? And the answer is cosine doesn't start at the origin. Cosine starts at a max, or in this case a min. So that is a little bit tricky, especially for cosine, because you don't start at the origin. So you still mark the new origin, but cosine doesn't start at the origin. Question?
How do you know, like, what the maximum is? If it doesn't have, like,
Oh, it doesn't have a number, so we didn't talk about it. I didn't ask for it. So what is the amplitude of this graph? 1. Because there's not a number out front, so it's 1. So I would just go 1 up and 1 down. Let's do 19 because I feel like we haven't graphed tangent in a while. Tangent of x minus 1. So the only change to the parent function is down 1. And don't forget, on this worksheet and on the test, you've got the parent functions as 1 through 6. Right? So if you're thinking, oh, what does tangent look like? Well, then you can be like, oh yeah, I answered that already. I think that was number 4 here is tangent. So I'm going to take the graph of number 4 and just move it down 1. And I would not accept that as an answer, but that's what you're going to do. Right? Move number 4 down 1. So I am going to do the new asymptote, or excuse me, the new origin, down 1. Tangent goes through the origin, so I can put a 0 there. What's the period of tangent? Here's the main reason I wanted to work this problem. Pi. That's the one that's different. So that means pi away, we're doing the same thing as we're doing at the origin. That's what it means to be repetitive, or cyclical, or have a period. So every pi, we've got a 0, because the period is pi. And what's going on in between the zeros? Asymptotes. And for tangent, all you need are the zeros and the asymptotes. So there's my graph of tangent. Again, compare that to number 4. Yeah, that looks like number 4. It's hard to see the labels on number 4, but the graphs look the same, except we moved ours down one. Number 25. Just because we like these 1, 2, 3 problems. Make you think a little bit. But you're used to these. The period, okay, Noah, there's the question for you here. The period of this first one is 2. Well, the period is 2 pi over b. What's b on that first equation? 1 over pi. So 2 pi over 1 over pi. Uh-oh, this is an algebra trick more than anything. Do the pi's cancel? Because if the pi's cancel, that's a true statement. If they don't cancel, it's not a true statement. Let's do keep it, change it, flip it if we're not sure. It is 2 pi squared. Which would be a terrible period to graph, but we're not asking you to graph it. The reason they don't cancel is the 2 pi in the numerator is the top part of a fraction. The pi in the bottom is the bottom part of a fraction. So you can't cancel a top with the bottom. If they were both in the top, sure. If they were both in the bottom, sure. If you get confused on that, keep it, change it, flip it, and be safe. Alright, so one is out. Anything with 1 in it is tossed. Horizontal shift, this should be a little easier. That's the minus 5 pi over 6. So 5 pi over 6 to the right. That is true. So we need 2 to be true. And so it comes down to whether 3 is true. The amplitude of this graph is -3. Oh, this was the main reason I wanted to pick this problem. Is that true or false? False. Good. False. You get kind of tricked into thinking, oh, that number out front's the amplitude. Like not exactly. Amplitude is never negative. So that one's false. So only number 2 is true. So be careful with amplitude. Amplitude's always positive. And then the last one I wanted to look at, or the last of my picks anyway, is number 31. Because it's one of the graphs without the grids. So we'll have to put the grids on. But on those problems, we try to walk you through what you need. Which makes for a great popsicle stick opportunity to ask all these different questions. One, two, three, four, five. So in order, Danny, vertical reflection, that's just a yes or no question.
Yeah.
Why yes? Good. Jake, amplitude? No, it's not none. Remember, amplitude this is still going to be a sine graph. So how high above it'll be 2 above the midline. Okay, good. So it's not -2. The negative is part of the vertical reflection thing. The amplitude is 2. Brandon, how about the horizontal shift? Right pi. Austin, the vertical shift? up 2. And Cecilia, the period?
2.
Well, be careful. B is 2. So the period is pi. So be careful how you answer the period question. You don't just grab B and stick it there. You got to do the 2 pi over B. Okay, shifts first to find the new origin. Right pi and up 2. Right pi. But my whole period is pi. So I don't want to go, obviously I don't want to go way too far over because then I'll run out of room. But also if I put it too close, then my graph's going to be really squinched up. So I think I'm going to go about halfway, because I know that one cycle, one period, is going to fit between 1 pi and 2 pi. Let's see, vertical shift is up 2, but then my amplitude is 2. So what's the maximum height of this graph going to be? My midline is 2 and my amplitude is 2. I got to be able to get up to 4. So right pi up 2. There's my new starting point, or my new origin. Okay, sine graph. I feel like I've graphed that little bitty sine graph 100 times in the last week and a half. I hope you've graphed it 10 or 15 times. So it starts on the axis, starts at the 0, which means it ends at the 0. Halfway in between, we're still at the midline. And then halfway in between those is a max. Whoops, put that in the wrong spot. Say max. It's killing me, that wrong dot there. It's going to throw me off when I try to graph more of this thing. There we go. And then halfway between B and A is the min. Uh-oh. It's going too fast. Still not right. Why'd I mess up? Caught it just before I really messed it up. It's flipped. It's flipped. I was about to do it without the flip. So I need to flip those 2 points. So my zeros aren't wrong. Those are fine, because when you flip those, they don't go anywhere. But I almost mixed up the max and the mins because of the flipped. And honestly, I caught it because I glanced over here to double check all my pieces, and as soon as I saw vertical reflection, I knew I hadn't done the vertical reflection. All right, let's carry this back 1 period. So from pi to 2 pi is a period, from pi to 0 is a period. Let's see, the maximum is 4. We already answered that. The minimum is 0. Alright, in my mind that's the hardest type of problem, because you have to figure out the grid, and it's really tricky sometimes for people to get the grid spacing correctly.
So there's going to be one of those.
There is going to be one of those. Yep. The other 4 graphs will provide you the grid, so that's a little bit easier. Alright, do you have any questions from the odds? Okay, then you got the remaining 20 minutes, 25 minutes to work on evens or odds or whatever you need to do to be ready for tomorrow. The packet's due tomorrow. Obviously, we'll get started right away because it's not a block day, and we've had 2 full days of review. So come in ready to roll tomorrow. And I don't think timing will be an issue. And I don't know, I feel like you're prepared for this better than most. I guess we'll find out tomorrow.